at this one. Our index this time is 4. Since all of them have a 4 as their index, and this is multiplication, I can multiply what's underneath the radical sign. When I do that, I have my 4th root of 3 times 6 times 9. Well, 3 times 6 times 9 is 162. Y cubed times y squared, since they all have the same base, I can add their exponents. So 3 plus 1 is 4, plus 2 is 6, so y to the 6th. Now think about what's our goal. We've got to write 162 as a number to the 4th power. And it might not be exact, because it might not be a perfect cube or a perfect quad. So I've got to try to think of, okay, 2 to the 5th power. I'm thinking of 3 to the 3rd power. Trying to get those numbers, that biggest number you can, times something else that gets us up to the 162. So once again, a lot of trial and error in your calculators. Well, 162 can be written as 3 to the 4th, which is 81, and then times 2. Well, 81 times 2 is 162. And then y to the 6th, is 6 divisible by 4? No. So I've got to think about how do I write y to the 6th so that I can get some y's to come on the outside. Well, y to the 4th times a y squared gets us back up to that y to the 6th, but I have an exponent I can work with. Well, 3 to the 4th power, that was our ultimate goal because that brings the 3 on the outside. We have the 4th root of this leftover 2. Y to the 4th, we divide it by the index number. So 4 divided by 4 gives us 1, so it brings a y out. And we have a leftover y squared on the inside. Alright, so that's multiplication. Multiply if you can, but they have to have the same index in order to multiply them. And then simplify. Now one thing you learned yesterday is you're not allowed to have any type of radical sign left in the denominator. As Mrs. Anderson said in yesterday's lesson, you have to rationalize your denominators. So I'm going to use the same steps she did in the beginning yesterday. I'm going to go ahead and multiply the top and the bottom by the exact same denominator. I can do that because that simplifies to 1. This right here simplifies to 1, and when you multiply by 1, it doesn't change its value. And we know if we take a 5th root of 27 times a 5th root of 27, we're just left with 27. So in the numerator, we have 18x times the 5th root of 27. Well, I need to look at this square, I keep calling it a square root, this radical sign, this 5th root, and think, is there a number inside of 27 that you can write as the 5th power? Well, 2 to the 5th power takes us too much. And if we start with 2, we know we're beyond where we should be. 27, a lot of us think of as 3 to the 3rd. Well, 3 is not enough to get anything to come on the outside. I'd have to have 5 of something to get it to come on the outside. So this has to stay the 5th root of 27. Because there is no 5th power of anything that can come out. So the next thing I look at, after I look at my radical, I can't simplify that, is just my coefficients. Well, 18 and 27, we know 9 goes into both of those. So we end up with 2x, and then the 5th root of 27, all over 3. So the key is to look for your index number. Is there something that can be written to that index? If there is, 3 to the 3rd power, it comes out. When we have any type of other simplifications, you're always looking at this index. Is there something that can be written to the 5th power? No, there isn't. But you you have to start working with, okay, 2 to the 5th, 3 to the 5th, and then multiply any other number that helps you get up to that number that was originally underneath the radical sign. Operations, here we ended up with subtraction and like terms. After we found out that 24 actually has 3 2's in it, that 2 comes out and leaves us with the same term, a cube root of 3. Multiply them together, watch your bases, and then once again, always look at that index and determine, is there that many of something inside of that number? And then your exponents, you need to try to make them divisible by that index. So you might have to manipulate them so that you can get a number that is divisible by the index, but also have some leftovers. And lastly, rationalizing your denominator. Cannot have any type of radical sign in the denominator, so you've got to come up with ways to get rid of that radical sign. And always ask yourself, is your answer completely simplified?